understand right? Okay, this one, right. Okay, this one is called the position versus time graph. Okay, and the straight line here shows that the vehicle or the person is or the object is moving with constant velocity.
Okay.
Okay, now what does this mean? Now first of all, we look at the position time graph. Position time graph. Of course, later on we are going to look at the velocity time graph, but now we are still at displacement, the position time graph. So on this position time graph, they have marked 3 points, A, B, and C. They have marked 3 points.
Okay.
Now, the vertical axis represent the position. It is not the displacement, it is the position, right? Displacement is the difference in position, difference in position. Then on the horizontal axis, the the variable is time. The variable is time. So let us look at these 2 points, A and B. So A is the initial position, B is the final position. So the vertical difference, that means this green line, can you see a dotted green line here? Okay, this vertical line of a right angle triangle represents the difference in position. Then this horizontal green line here represents the difference in time, the difference in time,
Okay.
or the time interval, or the time interval. So what we normally do is we use the difference in position, delta x, divide by the difference in time, delta t. Okay, delta x over delta t, and this will give us the average velocity. So
Okay.
earlier on, we are not referring to the graph. We just refer to the formula. Oh, what is delta V over, delta X over delta T. But now, graphically, graphically, delta X over delta T means this length of this side of the, the triangle, the right angle triangle, divided by the other side of the right angle triangle. So it's delta x over delta t is actually the slope of this red line AB. The slope. In British textbook, they use gradient. You use
Okay. Yep.
gradient,
Mm-hmm.
gradient. So the gradient of this straight line. Okay. So delta x over delta t, our average velocity is actually the gradient of the line, of the red line. Okay. Now gradient of the red line also we have many parts. Okay, from B to C, from B to C, the change in position, the delta x here, right? The delta x is here, and the delta t, the difference in time, the time interval delta t is here. So we use delta x over delta t, we are actually finding the slope of this line BC. Now, because it is a straight line, the slope of BC and the slope of AB is the same. Now, if the slope is the same, that means the average velocity is the same. If the average velocity is the same, it means that they are traveling with constant velocity. Okay or not? Need
Mm-hmm.
to repeat or not?
No, no, understand.
Okay, never mind. I repeat. Now, graphically, our delta x over delta t is referring to the slope of this line. In other words, in other words, the slope of the line is the average velocity, right? Now, if you look
Mm-hmm.
at this here, the slope, well, this is a curve, you know. The slope, they have different slope. Different part of the curve, they have different slope. Okay, so that means for this graph here, they are traveling not with a constant velocity. The velocity change all the time. The velocity is changing all the time. But because this is a straight line, the slope is always the same. So that the velocity is the same all the time. So the graph like this means they are traveling with constant velocity. The graph like this means the velocity is changing all the time. Okay or not?
Mm.
So by looking at the graph, whether it is a straight line or whether it's a curve, you have to decide whether it's a straight line or a curve. If a straight line, the slope is always the same, so the average velocity is always the same. If it is a curve, the slope is different. The slope is different, so the average velocity is different, is changing all the time. Okay, right. So now coming back to this one, from A to B, the average velocity is delta x over delta t. So they are actually referring to this part of the graph. From B to C, okay, the the velocity is delta x over delta t. So they are referring to this part of the graph, okay. But both of them, they are having the same value because it's the same slope. Okay, right. So we move on to the next graph here. This next graph, the average velocity between any 2 points equal to the slope of the blue line connecting the 2 points. Oh, what are they talking about? Okay, now over here, they they are talking about the also the average velocity. But this time you look at the blue line connecting A to B. So they are
Okay.
actually finding out the average velocity from A to B, from A to B. Then you see the blue line is connecting A to C. They are actually finding the average velocity from A to C. It is not like somewhere in between from B to C. No, no, it's not from B to C. Okay, they are not finding from B to C. They are finding from A to B, A to C, A to D, A to E, and A to F, something like this. Okay, so the initial position is always A, is always A. So far, you know what they are trying to show you here.
Mm-hmm. Mm-hmm.
Okay, they connect A to B. Okay, A to B. Can you see that this is my delta x? This
Yes.
line, oh dear. Okay. Yeah. Okay. This will be clearer. Okay. This will be clearer. So this dotted line here is the delta x between A and B. Then this one. Oh, cannot, huh? Okay. Oh, okay. So this line here, the dotted line, the red dotted line here, from A until the bottom of B is your delta t. So the average velocity from A to B is delta x over delta t. They follow the slope of this blue line here. It is the slope of the blue line. Now, what the curve here shows what? The curve here shows that although this blue line is the average velocity, but the velocity from A to B is not really constant. It's not really constant. It's changing all the time. At first, the velocity is very steep. You see the green line here? The velocity is very steep. Then later on, it become less steep, less steep. Now, you ever heard about tangent to a curve or not? Tangent
Yes.
to a curve. Right. Now, the velocity that we calculate here, okay, never mind. I continue with this one first. Okay. Okay, we continue over here. Right. Okay. Now, what is this graph? This graph is the position versus time graph for the motion of a car with changing velocity. Over here is constant velocity, over here is changing velocity. Now the velocity is changing all the time because it's a curve, but then we are not going through point by point. We just want to know what is the average velocity from A to B, and is given by the blue line. Okay,
Okay.
now the word slope is often used to refer to the graph of this physical data here. All these dot dot dot, they are the physical data. Now, regardless of the type of data, the slope is given by the change in vertical axis divided by the change in horizontal axis. The
Okay.
slope carries units, okay? Now, because this delta x is actually the x here, so it is in meter, then the delta t is actually in second. So the unit for the slope is meter per second. So in other words, the slope is actually referring to the average velocity. We use dimension to check. You remember how we use dimension to check, right? So now we are using the dimensions to check. Oh, what is the dimension of this delta x? The dimension of delta x is meter. What is the dimension of delta t? Delta t is second.
Fine.
So actually
Second.
delta x or delta t is meter per second,
The
which
ohms.
means
Okay.
that the slope is actually the average velocity. Now the slope can be positive or negative. Okay. Now, what is this positive or negative? Now, can you see this now earlier on this part here, this blue line here? I use a thing to draw. Oh, never mind. I use this to draw. So this is your line AB, and the slope of this line AB is this delta x divided by this delta t here. So this value here is a positive number, okay? Positive
Okay.
number. So it means that the velocity is positive. It means that it is moving towards the right. It's moving towards the right. Now, I clear this thing first, huh? Okay. Now, if you look at from A to E, okay? Now, from A to E is this line here. This line here. A to E is here. A to E is here. Okay. Now, from A to E, what is the delta x? This is my delta x. This is my delta x. What is my
Okay.
delta t? This is my delta t. Okay. Now, this delta x over here is a negative number. This delta x here is a positive number. So it shows that we have a positive velocity and a negative velocity. So this negative here means that it is moving towards the left hand side. From A to E, it is moving towards the left hand side of A. Any questions so far?
No.
No. One more time. Velocity, it can be positive. That means the gradient of the blue line here is positive. And the gradient can also be negative. That means it's pointing downwards. And it is referring to this right angle triangle. Right? So positive means what? Positive means it is moving towards the right of A. Negative means what? Negative means it is moving towards the left of A. Okay, we go on. Right. Oh, this one, very nice. Now this one is talking about instantaneous velocity. Okay, instantaneous velocity means the velocity at that moment, at that particular point. It is not stretched over a time interval. Now, so far, what we have been what we have been calculating is the velocity over a time interval from 0 second to 10 seconds, from 5 seconds to 8 seconds. So we are calculating the velocity over a time interval. But in this case, when we talk about instantaneous velocity, it is actually the velocity at that particular point. So what is the difference graphically? Now, graphically, this blue line represents the average velocity, right? It is the delta x divided by the delta t, okay? So the blue line represents the average velocity from A to B. Now, if you want to find the instantaneous velocity, okay, the instantaneous velocity is actually also the slope of the line, but it is not the slope of the blue line. It is the slope of the green line which touches the curve at the point B. So this
Okay.
gradient of the slope of the blue line is the instantaneous velocity at the point B. Instantaneous velocity at the point B. So if I move this point B along the curve, so the instantaneous velocity of this point B is now a negative number. Okay, whereas earlier on the instantaneous velocity is a positive number, the green line, the
Mm-hmm.
gradient of the tangent at that point. Okay, where you look at the average velocity is the blue line. Okay, the blue line is this one, right? Is this over this. Okay, this one represents the average velocity. Then this one represents the instantaneous velocity. It is the gradient of tangent at that particular point. Okay, so let's say we read this one. The instantaneous velocity v is the limit of the average velocity at the time interval delta t become infinitesimally small. That means the delta t approaches zero. Now delta t approaches zero means not over a time interval, but it is at that particular time. Okay, let's say if it let's say here. Okay, let's say let's say here. Okay, here. Okay, now if you look at the point B, the point B is
Mm-hmm.
actually at 1.5 seconds here. B
Okay.
is 1.5 seconds. So I ask you, hey, what is the velocity of B at 1.5 seconds? The velocity of B, the velocity of B at 1.5 seconds. So the slope of tangent, or it is this one, 1.05 at this position. What is the average velocity from A to B? Now you see it is over a time interval from A to B. That means it is from 0 until 1.5. So the average velocity is this one, 3.3 meter per second. Okay. The If you look at this point B, the point B, the height, here, this length here is 4.95, and this
Okay.
actually represents the distance in meter. Okay, then you look
Mm.
at the point B also, this distance here, which is the delta t. Delta t is the time interval, okay, which is 1.5 seconds. 1.5 seconds. So delta x over delta t, which is the slope of the blue line, is 3.3 meter per second. You use y divided by x. This is the delta x over delta t, and this is the average velocity. Okay, the average velocity. Okay, the average velocity. Now, average velocity is over a time interval from 0 to 1.5. Then what is the instantaneous velocity? The instantaneous velocity is the gradient of this blue line. It is the velocity at that particular time, 1.5 seconds. Okay, so at that
Mhm.
particular time, 1.5 seconds, what is the gradient of this line? 1.5 meter per second. Okay, so as we go along the curve here. Sorry, this one I shouldn't be holding this up. As I move along the curve, you see the average velocity can change to the instantaneous velocity can be negative. Then as you turn down here, negative, then become zero, then go up again, it become positive again, right? But if you look at the average velocity, which is this number here, the average velocity is the blue line. It is always positive. It's always positive, right? It's always positive. Okay. Any question? Uh,
No.
so let me summarize what you need to know. You need to know two things: instantaneous velocity, which is the gradient of the green line; instantaneous velocity, gradient of the tangent of gradient of tangent gradient of tangent. Then another one is the average velocity, the gradient of the line joining A and B, the gradient of the line joining A and B, the gradient of tangent at B. Okay, right. Next one.